Welcome, curious minds, to another deep dive. Today, we're plunging headfirst into the fascinating, intricate, and often surprisingly dramatic world of SAP system management.
That's a good way to put it. Dramatic.
Right. If you've ever found yourself wondering how these large-scale enterprise systems, the very backbone of countless global businesses, are kept running smoothly, how critical changes are moved safely from, say, a developer's desk to leave production environments, or how crucial complex updates get applied without bringing everything to a grinding halt.
Which is always the fear.
Exactly. Then this deep dive is absolutely for you. We've taken a really deep look at some incredibly insightful discussions around the core tools and processes that, well, keep these massive SAP landscapes humming.
We really have.
Our aim is to extract the most important nuggets, the key bits of knowledge, so you can cut straight to being well-informed.
Indeed, and we're talking about the fundamental operational layers here.
Yeah.
The things that underpin, really, the vast majority of major corporations worldwide. So today, we'll be unraveling the critical functions of SAP transports, really understanding the indispensable role of add-ons and plugins.
Freestanding things, yeah.
Exactly, extending capabilities, and then demystifying the truly powerful and sometimes, let's be honest, intimidating software update manager, the SUM tool.
SUM, yeah, I've heard about that one.
Our mission today is to give you a comprehensive yet, accessible understanding of these complex operational layers, complete with some surprising facts and hopefully practical insights you can actually apply.
Okay, let's unpack this then. Let's get right into what makes an SAP system truly tick behind the scenes.
Yeah.
How do we ensure that continuity and, well, the evolution of business processes, navigating SAP transports, the movement of change? So first up, let's talk about transports. It sounds almost too simple, doesn't it?
It does.
Just moving something from A to B. But in the SAP world, it's far from trivial. It's a foundational concept, the absolute backbone for managing change and keeping things stable. So what exactly are we transporting, and why is this mechanism so critically important?
You're absolutely right. The simplicity of the word, it really belies the immense complexity and criticality of the whole process. At its core, transports are how changes get moved.
What kind of changes?
Well, it could be configuration settings that define specific business rules, maybe new program code written by developers, or even critical master data that needs to be replicated across different systems.
Okay.
And it's moved between different SAP systems in a structured landscape. Think of it as a highly controlled, auditable, and exceptionally secure pipeline.
A pipeline for changes. I like that.
Exactly. This pipeline propagates all the development work done in, say, an isolated development environment, your DEV system, over to a quality assurance system, QA, for really rigorous testing and validation.
Makes sense. Test before you go live.
Precisely. And then eventually to the live production system, PROD. That's where the business operations actually run, generate revenue. Without this structured movement, honestly, you have pure chaos.
I can imagine accidental changes hitting production.
Oh, absolutely. Accidental changes, untested code, inconsistent configurations.
Yeah.
They could easily disrupt live business processes, and that leads to significant downtime, financial losses, reputational damage.
Yeah, big problems.
So transports ensure stability, reliability, and most importantly, business continuity. The primary purpose, like I said, is moving these changes efficiently and safely along that pipeline. Dev to QA, QA to prod.
And how's that orchestrated? Is there a main control panel?
Yes, the entire process is orchestrated through a central transaction code, STMS. That's your gateway, your central control panel for the transport management system.
SPS. Got it.
Now, when you're performing imports using STMS, it's absolutely crucial for administrators to understand something. Performing these imports on client 1000 of an SAP system, well, it affects all clients within that system.
Okay, hold on. STMS is the gateway, but client 1000. That sounds particularly powerful, maybe even a bit dangerous. Why does client 1000 have this unique status? Why the caution?
Yeah, caution is definitely the right word. Think of client 1000 as maybe the SAP system's central nervous system, or its global control panel.
Okay.
Unlike other clients, which might represent specific business units or countries or logical divisions, client 1000 is where the core system-wide configurations and master settings live.
So changes there aren't just for one part of the business.
Exactly. Changes made in client 1000 aren't confined to a single business unit or a specific operational client. They ripple across the entire SAP instance.
Wow.
Which makes it incredibly powerful, right? Because system-level configurations, certain types of imports that need to affect the whole landscape, they're executed here. But that power, it comes with immense responsibility. A misstep in client 000, it can affect every single business client, every user, every process on that instance, potentially causing system-wide disruption.
So definitely a place for experienced hands only.
Absolutely. You need administrators who truly understand the profound impact of their actions in there.
Okay, that makes sense. STMS is the command center, client 00 is the master switch. But how does SAP know where to send these changes? And in what order? Is there like a central brain orchestrating all this across the whole SAP landscape?
Exactly right. That's precisely where the domain controller comes into play.
The domain controller.
Yeah. And it's not just another system in your landscape. It is the central brain. It acts as the traffic controller, the master choreographer for your entire transport management system configuration across all connected SAP systems.
So it manages the whole setup.
Yes. For instance, in a typical three-system landscape, dev, QA, and prod, the development system is very often designated as the domain controller. It dictates how changes flow, ensuring the correct sequence, dependencies, the path from dev through QA, finally into prod.
And that centralized control is key.
Absolutely vital. For consistency, preventing conflicting configurations, making sure your entire SAP landscape operates as one cohesive unit.
Okay, and where does this master plan live? You mentioned configuration info.
Right. All the critical TMS configuration information, things like transport profiles, which define how transports behave, the very structure of your transport routes, it's all meticulously stored in a specific operating system directory. Usurp Transpin.
Okay, why is knowing that specific path important for an admin? Is it just like trivia?
Not at all. It's highly practical, actually. Knowing that path, Usurp Transpin, is crucial because that's where you find the essential configuration files for your TMS.
Right.
It's your first stop if you ever needed to, say, back up your TMS configuration or restore it, or troubleshoot really deep-seated issues related to how transports are behaving. Maybe if certain transport profiles aren't working as expected.
Okay. And security, too, I guess.
Definitely. It's a key area to secure. Unauthorized changes there could compromise your entire change management process. So yeah, less trivia, more like forensic analysis or disaster recovery for your transport system.
Got it. So the domain controller sets the rules of the road. STMS is how you drive on it. But what about the roads themselves? Are there different types of routes or layers for these transports, or just one path?
Good question. And yes, the road analogy works quite well. We have two main types of transport routes that define the logical path changes take.
Okay, what are they?
First, there's the consolidation route. This is typically used to move changes from your development system to the quality assurance system, QA.
Consolidation, like bringing things together.
Exactly.
Yep.
In the QA system, all the various development efforts from different teams or projects are consolidated, brought together for integrated testing. This is where you test how new features interact with existing ones. Critically important.
And the second type?
That's the delivery route. This handles the movement of thoroughly tested and approved changes from QA to the live production system, PROD.
The final step.
Right. This separation ensures that only fully validated, signed-off changes reach your operational environment.
Makes sense. And you mentioned layers, too.
Yes. Beyond the routes, there are also two types of transport layers. These categorize the types of changes being transported, adding another level of control and organization.
Different categories of change, like what?
Well, you have the standard SAP layer. This is reserved for changes to SAP's core components or the standard configurations that came, out of the box.
It's like a standard SAP stuff.
And then, crucially, there's the customer-specific ZSID layer. This layer is reserved for all your custom developments or configurations that are specific to your organization's unique requirements.
Z or Y objects, usually.
Often, yeah. Custom objects often start with Z or Y as a naming convention, or they might incorporate your SAP System ID, SID. This clear separation helps tremendously in managing different types of changes.
How so?
It ensures your custom developments don't inadvertently interfere with standard SAP functionality during, say, upgrades or patching. And it just provides better clarity for ongoing maintenance and support.
That's a lot of structure for just moving a simple change. So when you actually make a change in SAP Configure a process, write some code. How does it get packaged up for transport? Are there different kinds of containers, and why is knowing the difference important?
Absolutely. When you make any modification, it gets captured within what's called a transport request. These requests are like intelligently designed containers for your changes. They bundle everything together for controlled movement.
Okay, containers. What types are there?
There are a few key types that are fundamental. First, the customization request. This is specifically for configuration changes.
Like setting up new company codes, that sort of thing.
Exactly. Non-programming changes, setting up company codes, defining GL accounts, adjusting sales org structures, configuring purchasing processes, basically tailoring standard SAP to your business without writing code.
Got it. What's next?
Then we have the workbench request. This type is used for development object changes.
Ah, the coding stuff.
Right. New ABAP programs, modifications to standard programs, creating new database tables, developing custom reports, interfaces, even new Fiori apps. These usually involve coding and require a developer's expertise.
Okay. Customization and workbench. Any others?
There's also the transport of copies. This is often used for specific temporary movements.
Temporary. Like for what?
Maybe you need to copy some changes to a specific test system just for a quick review by a business user, but you don't want to set up a permanent transport route. It's flexible, often disposable.
So customization and workbench are the main ones for projects.
They're the workhorses, yes, for day-to-day operations and project deployments. But understanding transport of copies can save time in certain scenarios.
Now, these aren't just arbitrary labels, right? Customization versus workbench. Why is it so crucial, maybe especially for governance or risk teams, to understand that difference? What's the hidden risk if they're just treated the same?
That's an excellent point. And no, the distinction is anything but arbitrary. It's absolutely fundamental to risk management and project governance. If you treat them interchangeably, you invite significant risk. A customization request primarily deals with data in configuration tables. Important, yes, but the impact of an error might be limited to a specific process or user group.
Okay.
A workbench request, however, deals with program code, database table structures, other core development objects. A faulty workbench request can have far-reaching system-wide impacts. It could lead to program dumps, data corruption, even complete system instability if it's not handled meticulously.
Wow, okay. That's a big difference in potential impact.
Huge. And the hidden risk really lies in testing and accountability. Workbench changes often need much more rigorous testing unit tests, integration tests, maybe even performance testing because they involve code.
Right, code can break things in unexpected ways.
Exactly. Customization changes still need testing, of course, but the scope might be different. If you don't distinguish, you might seriously undertest a critical code change, thinking it's just a simple configuration tweak.
And accountability.
That differs too. A workbench change often has a specific developer directly responsible. A customization change might involve functional consultants. Understanding the type dictates the required testing level, the approval process, and crucially, the potential impact if you need to roll back. It's about knowing what kind of beast, so to speak, you're unleashing into your landscape.
Knowing the beast, I like that. So once these requests, these containers for change, are created, how are they actually managed? Where are they stored in SAP? Is there a central place to see everything pending changes, completed changes? Sounds like a critical audit trail.
Yes, absolutely critical. Transport requests can be created using several transaction codes depending on the context. Common ones are SEO1, Transport Organizer, SEO9, Transport Organizer Workbench, maybe even SU10 for some user-related transports.
Okay.
But the actual import process, getting those changes from one system to another, that's done specifically within SDMS, using its imports functionality, that's where you select the request, review it, and kick off the move along your defined routes.
And the storage, the audit trail.
Right. All created transport requests are meticulously stored in an SAP database table called E070K.
E070K. This table acts as a comprehensive log, a registry of all transport requests, regardless of their status open, released, already imported. If you go into transaction SE16, SAP's data browser, and look up E070K, you can see everything.
What kind of details?
All the requests, their statuses, the objects they contain, who created them, when they were created, when they were imported. It's all there.
This E070K table, it isn't just a ledger, is it? What's the deeper insight here for an organization? Maybe one focus on compliance or just trying to fix problems quickly.
That's a very astute observation. No, it's far more than just a ledger. E070K is your single source of truth for every change ever attempted in your SAP landscape. Think of it as the ultimate forensic audit tool.
Forensic audit tool.
Interesting. For organizations in regulated industries, or even just those with strong internal controls, E070K is crucial for demonstrating compliance. It allows you to prove exactly who changed what, when, and why. An undeniable audit trail.
And for troubleshooting, it's an absolute lifesaver. If a new issue suddenly pops up in production, You can trace back recent transports in E070K to pinpoint which specific change might have introduced the error. It's the technical backbone of your change management. It enables both accountability and rapid troubleshooting. Without it, honestly, managing a large SAP environment would be a much higher stakes guessing game.
Incredibly powerful. Now, speaking of system evolution and audit trails, what happens when the landscape itself needs to grow? Maybe you add a new regional system or a dedicated training environment. How do you integrate that new system into this controlled transport ecosystem? How do you get it talking to the domain controller?
That's a great practical question, as SAP landscapes do evolve and expand frequently. Adding a new system to your existing domain controller, making sure it participates correctly in the transport flow, well, it's a very specific multi-step process designed for controlling consistency.
Okay, what are the steps?
First, you typically need to log into client 1000 of the new system you're adding.
Back to client 1000.
Yep. Where system-wide configurations are managed. You usually log in with a DDIC user, that powerful standard user for system admin tasks. Then, you run the STMS transaction code within that new system.
STMS again.
Right. The system will then prompt you for the name of the existing domain controller. Once you provide it, the new system essentially sends a formal request to join the transport domain. It's like asking for permission, a handshake request.
Okay, so the new system asks to join. What next?
The next crucial step is you log into the actual domain controller system itself, often your development system, again, typically in client 000.
On the controller side now.
Correct. And from there, you'll see the request from the new system waiting for approval. You then need to explicitly approve the addition of this new system to the domain.
So there's a manual approval gate?
Yes, and it's a vital security gate. Ensures only authorized systems join your critical landscape. After you approve it, you perform any necessary configuration on the domain controller side to properly integrate the new system. You define its role in the transport routes, maybe add new delivery routes or layers specific to its purpose.
And that ensures it fits in smoothly.
Exactly. This whole structured setup ensures changes can flow reliably to and from the new system as required, making it a full, secure participant in your SAP landscape. It really shows SAP's layered approach to change management.
Okay, here's where it gets really interesting, I think. Because despite all these structured processes, all the careful planning, things don't always go perfectly in the real world, right?
No, absolutely not.
What are the common headaches? The frequent points of frustration with transports? And more importantly, how do you fix them? Because I imagine a stuck transport can halt a lot of important business operations.
You've hit on a core challenge for any SAP administrator. When a transport request just isn't importing, or maybe even more frustratingly, it's taking an unusually long time without any clear explanation. It can cause immense frustration. And yes, it can genuinely halt crucial business processes if a needed change isn't reaching production.
A point of panic, you said earlier.
It can be. But thankfully, there's a pretty comprehensive checklist for troubleshooting these situations.
Okay, let's hear the checklist. What's first?
The first, and arguably most common, check when transports are stuck or slow, is the background job RDDDP.
RDDDP, what does it do?
This job is the absolute engine that drives the import process. It must be running, and running in a consistent status, for imports to proceed smoothly. If RDDDP isn't running, or if it's in some problematic state, your transports will simply pile up, going nowhere.
And how do you fix that if it's stopped?
You need to execute the report RDDNE WPP. You do this via transaction code SA38 in client 00. Running RDDNE WPP essentially reschedules RDDDP, gets it back on track, and that can often kickstart your stuck transports.
Okay, check the RDDMBDP job. What else?
Well, it's not just about the job running. Beyond RDDMDP itself, you must also check for sufficient free BTC work processes.
BTC, Background Task Coordinator.
Exactly. Background Task Coordinator work processes. Think of these as like individual processing units or task executors within your SAP system, the hands and feet doing the work.
Right.
RDDMPP needs these resources to actually execute its tasks. If there aren't enough free background work processes available, the job simply can't run efficiently, even if it's scheduled. It's like having a car ready to go, but with no fuel in the tank.
Makes sense. Need the engine, RDDMPDP, and the resources BTC to run it? What's next?
Next, you need to verify the status of critical remote function call destinations, RFCs.
RFCs, the connections between systems.
Precisely. They're vital communication channels allowing SAP systems to talk to each other across the network. For TMS, the two key ones are TMS ADM and TMS SUP.
TMS ADM and TMS SUP.
Yes. If these RFC destinations aren't functioning correctly, Maybe a password expired, maybe a network path is blocked somewhere, communication fails. And that will prevent transports from importing between systems. It's a common, often overlooked culprit.
Okay, check the RFCs. Anything else?
Finally, you must also confirm the status of the TMS ADM user in client 000.
The TMS ADM user.
Okay.
This is a powerful system-level user account. It's absolutely critical for the transport management system's internal operations. If this user is locked, or its password expired, or it has any other status issue, it will disrupt the entire transport process. TMS won't have the necessary permissions to execute its functions.
So, 4 key things then. The job RDDDP, enough BTC processes, the TMS ADM and TMS UPRFCs, and the TMS ADM user status.
That's the core checklist. It's vital to remember this. If any one of those 4 components isn't working correctly, your transport imports will likely fail or get stuck. They form a delicate chain, you see. A break in any link means a complete halt in the change process.
A delicate chain. Good analogy. And it's worth noting, sometimes a transport taking longer isn't actually a failure. It might just be due to the sheer volume or complexity of the objects it contains.
Ah, right. A huge change will just take time.
Exactly. A transport moving thousands of configuration settings or extensive new code will naturally take more time to import. Knowing the difference between slow and truly stuck is part of the art of administration.
That's an incredibly comprehensive checklist. It really sounds like being an SAP admin involves a lot of detective work.
It certainly can feel that way sometimes.
Are there any specific procedures or transaction codes used after a really major system event, like, say, a system restore or a database refresh? Things that relate to getting transports working again? I imagine those kinds of events could really throw the system off.
You're right to highlight that. System restores, database refreshes, these are major events. They can indeed disrupt the change and transport system, the CTS configuration.
So what do you use then?
The transaction SCO06 is often used in very specific scenarios, precisely after a system restore or a database refresh.
SCO6.
When you restore a system from backup or refresh its database from another system, the system's unique identifier often changes, or its previous TMS configuration might become inconsistent with the domain controller. It's effectively like giving the system a new identity.
Right. It needs to reintroduce itself.
Exactly. It needs to reestablish its place within the transport landscape. The purpose of SCO-Sync in these cases is to effectively reinstall or reinitialize the CTS configuration on that specific system. It makes sure it can correctly participate in the transport landscape again.
So it's like a reinstall of TMS on that box.
Essentially, yes. A reinstall of TMS and its related components on the affected system, bringing its transport configuration back into alignment with the domain controller. It's a critical step to ensure a newly refreshed system can receive or send transports properly.
Okay, that makes sense for technical recovery. But beyond just getting transports to move technically, how do organizations handle the human element? The crucial gatekeeping, like ensuring a change is formally approved by, say, the business or QA teams before it goes live into production. Is there an SAP native way to manage those QA approval procedures, or do companies tend to rely on external systems for that?
That is a critical point for any regulated industry or, frankly, just any well-governed SAP environment. Approvals are absolutely vital before any change, especially a business-critical one, hits your production system.
So does SAP handle it?
Yes, SEO does support an approval procedure. It's often integrated through its powerful workflow functionality.
Workflow. Okay. How do you set that up?
The first step is usually to activate the workflow functionality itself. We use transaction code SW3 for that. This initializes and configures the core workflow engine within your SAP system. That's the foundation for automating business processes and approvals.
SW3 to turn on workflow. Then what?
Once SW3 is active, the functional teams or the process owners can then maintain an approval list specifically for transports.
An approval list defining who signs off.
Exactly. This list defines who needs to approve a specific transport request. You specify user IDs, maybe email IDs for notifications, and you can establish a whole hierarchy of approvals.
So multiple sign-offs are possible.
Oh, yes. A change might need sign-off from the developer first, then maybe a functional consultant who owns the process, then perhaps a business process owner, and finally an IT manager. All before it can proceed to the next system in the route. Ensures multiple eyes, multiple layers of accountability.
That sounds robust. Do most companies use the built-in SAP workflow?
Many do. However, some larger organizations, or those with very complex approval matrices, maybe global change management processes, they often opt for more robust third-party tools specifically designed to automate and enhance these approval processes.
Any examples?
A common one that comes up in discussions is Active Control. These tools can integrate directly with SAP's transport system.
And what's the advantage of a third-party tool?
What's powerful about them is that once all the required approvals are granted within the third-party tool, often through a more user-friendly interface, maybe with richer auditing capabilities, the tool can then automatically trigger the transport import within SAP.
Automation. Eliminating manual steps.
Precisely. It eliminates manual steps and potential human error in that final import trigger. This can significantly streamline the release process while still maintaining all the necessary audit trails and controls. It often accelerates the pace of change without sacrificing governance.
Okay, so wrapping up this section on transports, what does this all mean for someone managing an SAP system? It sounds like a really complex dance. Checking background jobs, validating user statuses, ensuring network connections, navigating all these specific transaction codes, sometimes even integrating external tools. It's clearly far more than just pressing an import button.
It's precisely about comprehensive vigilance, deep technical understanding, and a very systematic approach. As you said, it's far more than a simple import. Imagine your SAP system as a living organism, right? Transports are its circulatory system, delivering vital changes. A single point of failure in any of those checks we discussed, a stopped job, not enough work processes, a broken RFC, a locked user, it can halt critical system changes.
And that hits the business directly.
Directly. It leads to delays in deploying new features, frustration among users, potential financial losses if mission-critical functions aren't deployed on time, or if an urgent fix gets stuck somewhere in the pipeline.
So understanding these checks is key to fixing things fast.
Exactly. Understanding these specific, often hidden checks gives you a systematic approach to troubleshooting. It allows administrators to quickly diagnose and resolve issues, ensuring the continuous, smooth flow of necessary business changes through the SAP landscape. It's about being proactive, knowing exactly where to look when something goes awry, and ultimately safeguarding your business operations. 2. Add-ons and plugins, extending SAP functionality.
Okay, so transports handle moving existing changes. But beyond that, SAP systems often need to adapt and grow, right? Adding completely new capabilities or maybe integrating with other platforms in the company's IT ecosystem, that's where add-ons and plugins come in.
Exactly, that's their role.
What's the fundamental difference between those two terms, add-ons and plugins? And why do organizations actually need them? I mean, can't standard SAP do everything out of the box?
Well, standard SAP is incredibly comprehensive, that's true. But realistically, no single system can fulfill every nuanced requirement of every single industry or every specific business process. It's just too diverse.
Right.
That's where add-ons and plugins become crucial. They are really indispensable for enhancing the system's capabilities beyond its standard delivery. They let you tailor it to specific business needs or connect it to that broader IT ecosystem. They allow organizations to leverage SAP's robust core while extending its reach significantly.
Okay, so definitions then. Add-ons versus plugins.
Let's clarify. Add-ons are typically larger, more comprehensive software components. They provide substantial additional functionalities to an existing SAP system.
Adding features inside SAP.
Right. They can be developed by SAP itself. Think of industry-specific solutions like SAP for retail or SAP for utilities, which extend core functions for those sectors. Or they can come from third-party vendors to meet very specific business requirements not covered by standard SAP.
Like what kind of specific requirements?
Oh, maybe advanced country-specific tax reporting features, or a highly specialized manufacturing execution system, MES, that integrates deeply with production planning, or perhaps a niche HR module for a particular regulatory environment. Think of them as major feature expansions or specialized business solutions that bolt onto your existing SAP instance. They get installed into your SAP system to expand its internal capabilities.
Okay, that's add-ons. What about plugins?
Plugins, on the other hand, are generally smaller software components. Their primary purpose is integration and communication.
Connecting SAP to other things.
Exactly. They're used to integrate an SAP system with other SAP systems, maybe different modules or instances in your landscape, or even SAP cloud services. Or, very commonly, with non-SAP systems.
Like Salesforce or legacy systems.
Precisely.
Huh.
Could be a CRM like Salesforce, an external reporting tool, the legacy system, maybe even an IoT platform. Plugins act as connectors, enabling seamless data exchange and process flow between these disparate systems. They ensure information flows freely across your enterprise.
So both are installed based on business needs.
Yes, based on specific business requirements and system usage, either to extend functionalities within SAP add-ons or facilitate crucial integration with external functionalities, plugins, creating that truly interconnected enterprise.
Okay, so add-ons are like big feature packs deepening SAP's capabilities. Plugins are more like specialized connectors, broadening its reach. How do we actually install or update these in an SAP system? Are there specific tools for that?
Oh yes, definitely not a manual process for something of SAP scale. There are specific transaction codes and tools dedicated to installation and updates, designed for efficiency and control.
What are they?
For installing new add-ons and plugins, the primary transaction code you'll use is SAINT. That's the add-on installation tool.
Saint. Okay.
This tool guides you through deploying new software components into your SAP system. It manages dependencies, installation steps, usually automatically. It's kind of a wizard-driven process that makes these complex installations manageable.
And for updating existing ones, if a new version comes out.
To update existing add-ons and plugins, you typically use SPAM. That's the Support Package Manager, often in conjunction with SAINT.
Spam? I thought that was for SAP's own patches.
Primarily, yes. SPAM is mainly for applying support packages, collections of corrections, enhancements, legal changes for existing SAP components. But SAINT can also handle updates concurrently with new installations. So if you're installing a new version of an existing add-on, SAINT can manage that update process as well, integrating new features or compatibility updates for that specific add-on.
Okay, so Saint for new installs and sometimes updates. Spam mainly for SAP patches, but can help with add-on plugin updates too. Sounds straightforward. Is there a catch? Can you use Spam and Saint for everything in SAP? What are the really core ports of the system, like SAP Basis? I'd imagine those are handled differently.
That is a crucial distinction, and you've hit on a very, very important point for anyone managing an SAP system. While Spam and Saint are indispensable for managing add-ons and plugins, you cannot update core SAP components using them anymore.
Cannot. So Basis updates, core application updates.
Correct. Things like SAP Basis, the foundational technical layer, or the core application components like ERP or S/4HANA itself, you can't update those using Spam or Saint. Now, maybe way back in older releases, these tools were used for some core updates, but that approach has changed significantly.
Why the change?
Mainly due to the increasing complexity of SAP landscapes, the intricate interdependencies between all the components, and frankly, the need for more robust, controlled, and often downtime-optimized update processes for those critical core parts.
So what do you use for core updates then?
Updating core components now requires a much more powerful and comprehensive tool, the Software Update Manager.
SEM.
SEM again. Yes. This tool doesn't just apply packages. It orchestrates entire system transformations. It operates using what's called a stack.xml file.
Stack.xml. You mentioned that earlier with transports, I think. Or was it SEM?
With SEM, yes. It used to be called dag.xml sometimes, but stack.xml is the current term. This file is generated exclusively from SAP's cloud-based maintenance planner.
Maintenance planner.
And that stack.xml file essentially provides a detailed blueprint of the target system state. It lists all component dependencies, the specific target versions, the precise upgrade path. Without this stack.xml file, you simply cannot perform core component updates or major upgrades using SML.
So Spam and Saint for the modular extensions, but anything touching the core system needs the heavy artillery of SUM, guided by that stack.xml blueprint.
You've got it exactly right. That's the fundamental divide.
And what about downtime? That's always the big question for the business, right? How long will the system be unavailable? Is there a big difference in downtime when using Spam Saint versus using the SAP tool for these different kinds of updates?
Absolutely. Downtime is often the most critical business consideration when planning any SAP maintenance. And yes, there's a significant difference based on the tool.
How so?
When you're using Spam and Saint for add-on and plugin updates, generally there's no need for planned extensive downtime for the entire system.
Really?
Minimal disruption. Relatively minimal, yes. These tools are designed to apply changes to specific modular components. The system often remains operational or might require only very short, localized, planned outages for specific activation steps, if anything at all. This makes them relatively non-disruptive for regular maintenance of add-ons and plugins. Businesses can usually continue operations with minimal impact.
Okay, that's good for add-ons. But SUM for core updates?
That's different. When you're using the SEM tool for core component updates, major system upgrades, or even database migrations, you can, and more often than not, you must plan for specific dedicated downtime windows.
Must plan for downtime, okay.
SEM operations, because they're so comprehensive, touching the very foundation of your SAP system, they involve bringing down the main production system for a period to perform the actual upgrade or conversion. Now, SEM offers sophisticated features and scenarios to minimize this unavailability.
Like that near zero downtime thing.
Exactly, like NZDM. But some downtime is usually inherent in the process. The key difference is that LTM provides much more control over when this system unavailability occurs. It allows organizations to schedule it carefully, maybe during low-impact hours or weekends, precisely because the changes it manages are so foundational and potentially disruptive to the entire business. This difference in downtime philosophy is a key differentiator between the tools and really dictates how you approach your overall maintenance strategy. 3. The SUM tool, mastering system upgrades and transformations.
Okay, so if SPAM and SAINT are for add-ons, then the SUM tool truly sounds like the heavyweight champion. For major system changes, transformations, it's not just an update, it sounds like something much bigger. What exactly is SEM, and what kind of powerful, often business-critical operations can it really perform?
Heavyweight champion is a good description. What's truly fascinating here is that SEM, the software update manager, is indeed far more than just a tool for applying patches. It's a comprehensive upgrade and transformation manager. It's essentially the orchestrator for profound, significant changes to your SAP system.
The orchestrator.
Yeah, think of it as the Swiss Army knife for major SAP landscape evolution. It's designed to manage the staggering complexity involved in modern enterprise systems.
So what does it do specifically?
At its core, SUM is an advanced, powerful tool used for updating, patching, and upgrading virtually any SAP system component to higher levels. It's built to navigate that intricate web of interdependencies between different SAP modules, databases, operating systems. Its diverse use cases really highlight its power and strategic importance.
Okay, like what?
Well, first, applying patches and support packages, SPS. This is its most frequent use, keeping your system current with the latest fixes, minor enhancements, legal changes for individual components, multiple components, or the whole SAP stack. Ensures stability and security.
Standard maintenance, basically.
Right, but as it gets bigger, performing full release upgrades. These are major version changes, like moving your entire SAP ECC 6.0 system from an older enhancement pack to a much newer one, or even to a different major version of an SAP product. Crucial for getting new functions, better performance, staying within support.
Okay, upgrades. What else?
Facilitating database migrations. This is where SEM's power really shines. It's indispensable for migrating your entire SAP database from one platform to another, like moving from Oracle or SQL Server or DB2 to the SAP HANA database.
The HANA migration, that's a big one.
Huge. It's a complex, data-intensive operation, and SEM manages it meticulously, ensuring data integrity and consistency throughout that transition.
And the biggest one, S/4HANA.
Exactly. Handling major system conversions. Critically, SUM orchestrates fundamental architectural shifts, most notably that conversion from the traditional SAP ECC system to the next-gen SAP S/4HANA. This isn't just an upgrade, it's a reimagining of the core business suite. SUM handles the immense technical complexity of that transformation, including data model changes, replatforming the works.
That's an enormous range of capabilities, from minor fixes all the way to fundamental replatforming. How do you even get started with a tool like that? How do you access it? Does it run right on the SAP server, or is it remote?
Yeah, it definitely runs on the SAP server. Specifically, it has to run on the primary application server of the system you're upgrading.
The primary instance.
And a mandatory prerequisite for starting SEM is the SAP host agent.
Host agents.
Yeah, it's a lightweight process that runs continuously on the OS of your SAP service. It provides essential services for SAP applications, including managing SUM operations, collecting system metrics, facilitating remote communication. Without a running SAP host agent, SEM simply cannot initiate or monitor its processes.
Got it. Host agent must be running. How do you launch SUM itself?
The tool is initiated using a command line interface directly on that primary application server. A typical command might look something like some start.batconfig host agent SID, where SID is your SAP system ID.
Okay, command line to start. Where do you manage it?
Right, once started, SUM doesn't operate within the traditional SAP GUI. Instead, it operates via a web browser interface.
Ah, web-based.
Correct. You access it by opening a specific URL in your browser, usually pointing to the application server on a specific port, like 1129 or maybe 4239. This web interface is where you interact with SUM, you monitor its progress through detailed logs and status updates, and you provide inputs throughout the whole multi-phase upgrade process.
So it gives you direct control from the server via the web.
Exactly. It ensures stability even if the SAP application layer itself is undergoing major changes during the process.
You mentioned earlier that a stack.xml file is absolutely crucial for SUM. Can you elaborate on why that file is so important and where does it come from? It sounds like more than just a simple config file.
This is an absolutely critical point. You cannot overstate its importance.
Okay.
The stack.xml file. It is the mandatory key for any SUM operation involving core component updates or major upgrades. Without it, you cannot proceed, period.
Mandatory key. Okay.
Trying to run SUM without this file is like trying to assemble a highly complex customized engine without a blueprint or an instruction manual. You'd be risking incompatible parts, guaranteed failure.
So what's in the stack.xml that makes it so vital?
It essentially contains the entire meticulously calculated blueprint for your target system state. It specifies the exact target release and support package levels for all the different SAP components you're updating. It details all the complex component dependencies, which component relies on which other one for compatibility. And it includes other vital info for the precise, valid upgrade path. It's not just a list, it's an intelligent map guiding SUM, ensuring compatibility and consistency across maybe hundreds or thousands of software objects.
And you don't create this manually?
No, definitely not. It's generated using SAP's cloud-based application, the Maintenance Planner.
The Maintenance Planner again.
Yes. The Maintenance Planner helps you plan and maintain your landscape, ensures you have the correct software versions and dependencies, identifies conflicts, and then it produces this definitive stack.xml file. So before you even think about starting an XM upgrade, your first indispensable step is always go to the Maintenance Planner, define your target system, generate that stack.xml. It's your guarantee of a valid upgrade path.
Okay. Stack.xml is the master plan generated from the cloud. Got it. Now, given how comprehensive SUM is, are there different ways it can approach an upgrade? Maybe ways to minimize downtime for really critical systems? Or just manage the complexity? I think I've heard terms like near zero downtime maintenance.
Yes, SUM is remarkably flexible. It offers different scenarios designed to optimize the upgrade process based on your specific business needs and, crucially, your downtime tolerance. These scenarios let you tailor the upgrade methodology to best fit your operational requirements and risk appetite.
What are the main scenarios?
Well, the primary ones include the standard scenario. That's a general-purpose approach, suitable for many upgrades, where a typical downtime window is acceptable. Then there's the single scenario, often used for simpler or more focused updates with less complex landscapes.
And the optimized one.
Right. For many enterprises, especially those with critical 247 operations, where even an hour of downtime means significant financial loss, the downtime optimized scenario is incredibly appealing. This scenario includes advanced options designed explicitly to minimize system unavailability during the upgrade.
And that's where near zero downtime comes in, NZDM.
Exactly. The most notable and sought after of these options is near zero downtime maintenance, or NZDM.
How does NZDM work conceptually?
It employs sophisticated techniques, like creating that shadow system we touched on, leveraging parallel processing, clever data synchronization, all to keep the production system running for as long as possible during the upgrade. It shifts most of the heavy lifting, the resource-intensive upgrade work, into the background while users continue working on the live system.
So the actual downtime is much shorter?
Much shorter. It only requires a very short final downtime phase for the actual cutover to the newly upgraded system. Now, while NZDM significantly reduces downtime, it often requires more system resources, more advanced planning, and can introduce a higher degree of complexity in the planning and execution phases.
A trade-off, then. Less downtime, more complexity and resources.
Precisely. So, choosing the right scenario is a strategic decision. You balance the business's need for continuity against the technical complexity and the resource investment required. It's really a testament to SAP's continuous efforts to make these complex changes less disruptive.
That's truly advanced. It sounds like a massive undertaking, though, involving multiple stages, lots of planning. Can you walk us through the major phases of a SUM operation? What happens at each distinct stage? And what are the critical checkpoints or actions for an admin to watch out for?
Yes. This is perhaps the most detailed and critical aspect of understanding SUM. It is a multi-stage, highly orchestrated process, and specific, crucial actions happen at each phase. Missing a critical checkpoint can lead to significant issues down the line.
Okay, phase by phase then. What's first?
SUM operations proceed through several distinct phases. It starts with 1, extraction.
Extraction. Sounds like getting things ready.
It is. This is the initial preparatory phase. SUM extracts all the necessary files, archives, software components from the downloaded packages you've placed in a designated directory. It prepares all the raw materials needed. It's largely automated but needs enough disk space.
Okay, extraction done. What's next?
2. Configuration. In this phase, you interact with SUM's web interface to set up various parameters for the upgrade.
Like what kind of parameters?
Defining network settings, confirming basic system details, selecting the upgrade scenario we just discussed, standard, single, downtime optimized, specifying any specific options relevant to your landscape. It's about tailoring SUM's behavior to your specific environment.
Makes sense. Tailoring the run. Phase 3.
3. Checks. This is a crucial validation phase. Often prevents major issues later on. SUM performs numerous system readiness checks.
What's it checking for?
It verifies prerequisites are met, system resources, disk space, memory, CPU are sufficient, database consistency looks good, and that there are no fundamental blockers that would prevent a successful upgrade.
And if it finds issues?
If issues are found, SUM will halt. It provides detailed logs, prompting you to resolve them before you can proceed. This is your chance to fix environmental problems before they derail the actual upgrade.
Okay, checks are vital. What comes after the checks pass?
4. Pre-processing. This is arguably the most critical and often the lengthiest phase before the actual downtime begins.
Pre-processing. This is where the shadow system happens.
Exactly. This is where the magic of the shadow system comes into play, especially for downtime-optimized scenarios. SUM creates this shadow system within your existing SAP Systems database. It's essentially a temporary isolated copy, but it operates on the new upgraded software binaries.
And the production system is still running.
Yes, that's the key. This shadow system is then upgraded first, while your main production system continues to run and serve users. This significantly reduces the eventual downtime window needed later.
Clever. What else happens in pre-processing?
2 critical activities. First, SPDD adjustments.
SPDD.
Stands for Dictionary Object Modifications. These are critical adjustments made by developers. They adapt any custom data dictionary objects like custom tables, data elements, domains that you might have modified or created in your existing system, making them compatible with the new upgraded structure.
When do developers do this SPD work?
They perform these adjustments at the very end of the pre-processing phase, immediately before the actual downtime begins. It's a crucial point of no return for these dictionary adjustments before the system goes down. Missing an SPD adjustment can lead to data loss or program crashes after the upgrade.
Okay, SPD right before downtime. What was the second critical thing in pre-processing?
The full system backup prompt. Crucially, SUM will prompt you, force you really, to take a full system backup during this pre-processing phase. This is not optional, it's absolutely mandatory.
Mandatory backup. Why then specifically?
Because this backup is your only reliable recovery point if catastrophic issues arise later, during the execution phase or post-processing. If you need to roll back for any reason after this point, your only strategy is to restore from this pre-processing backup. It's your safety net.
Got it. Pre-processing done, SPDD done, backup taken. Now what?
5. Execution. The actual downtime phase. This is the moment of truth. The main production system is actually brought down. All users are logged off. Business operations on that system stop.
Okay, system is down. What happens during execution?
During this downtime, the data and configurations from the already upgraded shadow system are effectively cut over or copied to the main production system. This cutover is relatively rapid because the bulk of the upgrade work on the shadow system was already completed during pre-processing.
And this is
This is the absolutely critical point. Once the execution phase has started, you cannot perform a reset or rollback through the SUM tool itself. The tool is designed to move forward only from here. Any rollback at this stage requires restoring the entire system from that full database backup taken during pre-processing.
the point of no return. Makes the backup even more critical.
Incredibly vital. It is literally your insurance policy against catastrophic failure during the riskiest part of the upgrade.
Okay, execution completes. System hopefully comes back up. What's the final phase?
6. Post-processing. After the main system is successfully upgraded and brought back online for technical verification, this phase involves crucial cleanup activities, like deleting the temporary shadow system. Activations and evaluations are performed to ensure everything is technically consistent.
And there's another developer activity here too, right? SPAU?
Correct. SPAU activities are performed during post-processing. SPAU stands for Repository Object Modifications.
Different from SPDD.
Yes. SBAU adjustments are for custom programs, reports, function modules, other development objects where you might have modified standard SAP code or created custom code that interacts with it.
And when do these SPA adjustments need to happen?
Unlike SPD, which has to be done right before downtime, SBAU adjustments can typically be done within 14 days after post-processing is complete.
More flexibility.
Much more flexibility. It gives developers breathing room and avoids immediate pressure during the critical downtime window and initial system startup. This phased approach helps manage the workload. Functional teams can begin initial testing while developers complete their SBAU adjustments in parallel or shortly after.
That's incredibly detailed. Wow. Given the complexity and length of these phases, how do you keep track of what's happening during such a critical process, especially if something goes wrong? And what are the absolute non-negotiables, the critical pre-steps, before you even think about kicking off a SEM upgrade?
Excellent questions. Monitoring and fulfilling prerequisites are absolutely paramount. They often determine success or failure. Without proper vigilance and preparation, a complex upgrade like this can quickly go off the rails, impacting your entire business.
So monitoring first. How do you watch SUM? Where are the logs?
SUM generates incredibly detailed logs at various levels. These are your primary means of monitoring and troubleshooting.
Where do you find them?
Well, within the SUM console itself, that web interface, you can find phase-specific logs. If SUM stops or hits an error, the console usually points you directly to the specific log file for that phase, giving immediate context.
Okay, console logs. What else?
There are also common, continuously updated log files, names like sap.log, slog, ulog. These give a high-level overview and capture important events throughout the entire process. They're like real-time diaries of the upgrade.
Where are these generally stored?
At the operating system level, more granular logs are typically found in a dedicated directory. UCSAP, SAC SUM block. This directory is a treasure trove of diagnostic info if you need to do a deep dive.
Any other key locations?
Details about the temporary shadow system, its profiles, configuration, are located in USAP's ID SUM BIPEX and a SAP's ID SUM BIP system. That's where the shadow instance binaries and profiles live.
Okay. And you mentioned an analysis file.
Yes, a particularly key analysis file for understanding performance and bottlenecks is upanalysis.xml. You'll find it in USAP's SAC SUM BIP analysis.
Upanalysis.xml. What's in there?
This XML file records timelines and durations for each individual step of the upgrade. It provides invaluable insights into the upgrade's progress, where time was spent, and where potential bottlenecks might have occurred. Excellent for post-mortem analysis or planning future upgrades, helping you fine-tune your approach.
That's a lot of logs to potentially comb through. But what if SUM itself stops? If it hits an error midway through, especially before that critical execution phase, can you just pick up where you left off? Or do you have to restart the whole grueling process from the very beginning?
That's a critical operational question. Thankfully, SEM is designed with some resilience in mind, but there are distinct limitations, as we discussed.
So, can you resume?
If SUM stops or encounters an error before the critical execution phase begins, so during extraction, configuration, checks, or pre-processing, you can often resume the process from precisely where it left off.
That's huge. Saves restarting everything.
It saves an enormous amount of time and effort, yes. If it's, say, 30% complete and hits an error, you fix the issue, restart SUM, and it should pick up from that 30% mark, continuing its meticulously recorded process.
Okay. Resuming is possible before execution. What about resetting, going back?
Similarly, a reset, which essentially means rolling back SUM's internal state and performing a cleanup of the SUM directories on the server, is possible if an error occurs during pre-processing or earlier phases. This lets you correct the underlying issue, clean up temporary SUM files, and attempt the upgrade again from an earlier consistent state.
But the big however,
and this is the absolute crucial takeaway, the non-negotiable point of no return we keep emphasizing once the execution phase has started. The point where the main production system is down and the cutover begins. A reset or rollback via the SUM tool itself is not possible.
Not possible at all through SUM.
Correct. The tool is designed only for forward movement at that stage. At that point, your only option for rollback is to restore the entire system from that complete database backup taken during pre-processing.
Which just underscores again why that backup is non-negotiable, your ultimate safety net.
It absolutely is. Your insurance policy against catastrophic failure during the most critical part.
So besides that vital pre-processing backup, which is clearly non-negotiable, what are the other absolute fundamental prerequisites, the critical pre-steps, the resource requirements that must be in place before you even think about starting SUM Ignoring these, I assume, just guarantees failure.
You are absolutely correct. Ignoring these prerequisites will guarantee failure, potentially wasting weeks of effort and causing major headaches.
Yeah.
Beyond the critical backup, there are several fundamental requirements.
Okay, let's list them. What's first?
1. Primary application server execution. The SUM tool must be run on the primary application server of the SAP system being upgraded, not a secondary instance, not the database server, not some other machine.
Only the primary app server. Got it.
2. Sufficient resources. This is frequently overlooked or severely underestimated. SUM requires substantial free disk space and adequate system resources, CPU, memory capacity on that primary application server, and often on the database server too.
How much is substantial?
Upgrades are incredibly resource-intensive. You often need to uplift or extend your system resources significantly beforehand. Add more RAM, more CPU cores, increase disk space, especially in SRSAP or the dedicated SEM directory. Insufficient resources lead to extremely long run times, bottlenecks, or outright failures. Planning for maybe 2-3 times the expected temporary space needed is often a good rule of thumb.
Wow, 2-3 times. Okay. Resources are key. What else?
3. Network stability and bandwidth. While not strictly ASUM setting, a stable high-bandwidth network connection between your application servers and the database server, if they're separate, is paramount. Any network latency or instability during critical data transfer phases can cause delays or failures. Especially true for large database migrations.
Makes sense. Stable network. Next.
4. Database health and consistency. Before you start SUM, ensure your database is in excellent health. No pending issues, no corrupt indexes, consistent data, recent database statistics updated. A healthy database provides a clean foundation and minimizes risks. Running full DB consistency checks beforehand is highly recommended.
Clean database. What about the SAP system itself?
5. Clean starting system. Your current SAP system should be in a clean state too. That means no pending updates or patches from previous attempts, no outstanding transport requests waiting, no critical system errors showing up in the application logs, like SM21. A consistent, stable starting point significantly reduces the chance of unexpected issues cropping up during the upgrade.
Okay, clean system. Anything else needed before starting?
6. SAP Download Manager. Well, not for running SEM itself, but you'll need the SAP Download Manager beforehand to actually obtain all the necessary software packages, the kernels, support packs, add-ons, database-specific files required for your specific upgrade target defined in the stack.xml.
Yeah.
Ensures you have the complete correct set of files ready before you even start SUM.
Right, gotta have the software first.
And finally, maybe most importantly, 7. Thorough testing plan. This isn't a prerequisite for the tool, but it's an absolute prerequisite for a successful project. A comprehensive, well-executed testing plan is vital. Unit testing, integration testing, regression testing, user acceptance testing, UAT, all at various stages, especially after the upgrade is complete. You can't just run SUM and assume everything works perfectly. Rigorous testing validates the outcome.
Testing. Crucial.
Absolutely. And just briefly, for completeness, it's also important for admins, especially in Linux environments, to understand the concept of global versus local mount points.
Mount points.
Yeah. SAP, often called SAP MNT, is usually considered the global mount point. It's a file system potentially shared across multiple instances or systems, holding common binaries, profiles, transport directories. SAP LOC usually represents a local mount point specific to an individual server, holding resources unique to that server instance. Understanding this file system organization is key for allocating space correctly, knowing where SEM puts temporary files and logs, and ensuring a robust system design overall.
Wow. Okay, that was a truly deep dive into the operational backbone of SAP. From the meticulous, highly controlled movement of changes via transports, to extending functionality with add-ons and plugins, and finally orchestrating these truly major system upgrades and transformations with the powerful SUM tool. It's abundantly clear that behind every smooth-running, mission-critical SAP system lies just a complex, carefully managed set of processes and tools, governed by really strict methodologies.
Indeed. We've really seen how each component plays a vital, interconnected role. From the domain controller guiding the flow of changes, all the way to that stack.xml file, dictating an upgrade's precise path and ensuring compatibility.
Yeah.
The interconnectedness of these tools, the foresight required in planning, and those specific, often hidden troubleshooting steps, they really highlight that knowledge is most valuable when it's understood deeply and applied systematically. especially in these mission-critical enterprise environments where, honestly, even a single misstep can have significant real-world business ramifications, financial losses, disrupted supply chains. The impact is real.
So what does this all mean for you, our curious listener? Whether you're maybe an aspiring SAP professional aiming to master these intricacies, or perhaps a manager overseeing a large enterprise system and needing to understand the underlying mechanics, or maybe just someone incredibly curious about how these digital behemoths operate. Understanding these tools provides a crucial shortcut to being well-informed. It really underscores the precision, the foresight, the systematic approach required to keep today's digital infrastructure robust, adaptable, and continuously serving the needs of global businesses. It's a world where attention to detail isn't just a virtue, it's an absolute necessity, and where mastery of this underlying plumbing directly translates to business resilience and ultimately competitive advantage.
And perhaps it leaves us with this thought to ponder. In a world that's increasingly reliant on these complex IT systems, systems that underpin nearly every major industry, from manufacturing to healthcare, finance to retail, how much is our deep understanding of this underlying operational plumbing, like these transport and upgrade mechanisms we discussed, how much does that understanding impact our collective ability, not just to maintain current operations flawlessly, but also to innovate, adapt, and build the next generation of digital capabilities?
Something to chew on indeed. Thanks for joining us on this deep dive. We really hope you feel a little more well-informed, maybe even empowered, in the fascinating world of SAP system management.